Question number 3. Jim records the length of 81 salmon. The data are coded using the equation x is equal to L minus 600 and the following summary statistics are obtained. Find the mean of this salmon. So here, this is the coded data and this is the coded summary and this is the total number. So they're asking to find the mean. So first of all, we will find the mean of this coded data. So how will you find the mean? The equation is sigma x divided by n. So sigma x means 3711 divided by 81. And if you're doing so, you will get 45.814 non-terminating. Okay. Now, using this coded data, we need to find the mean. So here we are interested to find the mean length of this salmon. Length is L. So the equation for the coded data is x is equal to L minus 600. Now you can apply mean to this as well. So that means x bar is equal to L bar minus 600. Therefore, L bar is equal to x bar plus 600. X bar we already got, or the mean of x is already got 45.814 plus 600. So that we will get it as 645.814. And if you are rounding this to 3 significant figures, so answer is 646 centimeters. Okay, so not centimeters, I mean this is measured in millimeters. So answer for this is mean length is 646 millimeter. That is the answer for this. So mean length is 646 mm. Okay. That is the answer for this. Okay, fine. Now, in the B question, they are asking to find the variance. So equation for the variance is sigma square x. First of all, we will find what is the variance of x. So sigma square x is equal to sigma x square by n minus sigma x over n whole square. Sigma x square, that is 4751.82. 475,181 divided by the number of observations, that means 81 salmons. So n is equal to 81. Minus sigma x by n. Sigma x is 3711 divided by 81 whole square. So please figure it out, that answer. That we will get it as 3767.43. 3767.43. 3767.43. And therefore, we need to find the variance of the original data. That means sigma L square. We revisit the coded equation once again. So x is equal to L minus 600. So what is the coefficient of L? It is 1. So therefore, if you want to find the variance of the original thing, what we will do is the variance of the coded one divided by the coefficient of 1 whole square. Not coefficient of not divided by a square times sigma x whole square. So here it is 1 square. 1 square times 37673.43. So that is 3763.43. And if you are rounding to 3 significant figures, so answer is 3770. So that is the answer for this particular question. Now move to the C part of this question. The weight W grams of each of these 81 salmons is recorded to nearest gram. The recorded results for the 81 salmon are summarized in the box plot below. Find the maximum number of salmon have a weight in the interval 4,600 to 7,700. How many marks for this question? It is 1 mark. So that means applying a simple thing or simple logic, we can answer this question. We don't want to do any higher kind of calculations here, correct? So identify where this is 4,600. So 4,600 is this. What is the speciality of 4,600? 4,600 is the mean. And 7,700 is the maximum value. 7,700. So that means we know that we need to find the value or observations above mean. What is the definition for mean? Not mean, I mean the median. So Q2 is the median. So please understand it as median, not mean. I mean here they are asking to find the maximum number of salmon whose weight is greater than median. So what is the mean definition for median? Median divides the entire data set into half. That means 50% of the data lies above and 50% of the data lies below. So what is the 50% of 81? 81 divided by 2. That is 40.5. So that means on an average, 41 salmon's weight lies below or exactly equal to 4,600 grams. That means altogether we measured 81. So 41 already measured below 4,600 grams. So that means above 81 minus 41. So that means it is 40. Clear? So the answer for this question is 40. Why it is 40? Because while taking the half of 81, we are getting 40.5. So that means we'll be rounding up to find the median. So median is 41. So that is the meaning. That means on an average, 41 salmons lies below or exactly equal to 4,600. So that means above 4,600, how many salmons will be there? 81 minus 41. That the answer is 40. It's a logical question. So answer for C part is 40. Now, Raj says that the box plot is incorrect as Jim has not included outliers. For this data, an outlier is defined as value is more than 1.5 times interquartile range above the upper quartile or 1.5 times interquartile range below the lower quartile. Show that there is no outliers. So here after, so answer for C is 40, right? So the D question, after reading box plot, the upper quartile Q3. What is the value of upper quartile? Upper quartile Q3. Upper quartile is this. This is upper quartile. So upper quartile is 5,400. Lower quartile is, this is 3,500, 3,800, correct? So the lower quartile is, upper quartile is 5,400 grams. Lower quartile is 3,800 grams. So as a result, we can calculate in IQR, that means interquartile range. So what is interquartile range? It is the difference between upper quartile and lower quartile. So that is 5,400 minus 3,800. So 5,400 minus 3,800 means that is 1,600 grams. Now see outliers below 1.5 times interquartile range of Q1. So that means Q1 minus 1.5 times 1,600. Q1 is 3,800. Q1 is 3,800 minus 1.5 times 1,600. So what is the answer? 1.5 times 1,600. That value we should subtract it from 3,800. So that we will get it as 1,400 grams. And outlier above 1.5 times interquartile range of upper quartile. So that is Q3 plus 1.5 times 1,400. No, 1,600, because interquartile range is 1,600, right? So 1.5 times 1,600. So upper quartile itself is 5,400 plus 1.5 times 1,600. So that value we will be getting it as 7,800. Now you go to the box plot. The smallest value is 1,000. This is 1,500. This is 1,600. The smallest value is 1,600, and the maximum value is 7,700. So we can go up to outlier is a value, any value below 1,100. No, an outlier is this is the box plot we are getting, correct? So this is the box, and the end value is 1,600. The smallest value is 1,600, and the largest value is 7,700. So any outlier is a value below 1,400 or any value after 7,800. So what is your conclusion? So here no values in this box plot, no values below 1,400 or no values after 7,800. So there is no outliers present in given box plot. So that is the answer for this question. Okay, so in this question, what all things we discussed? We discussed about coding, we discussed about finding the mean, we discussed about finding the variance, we discussed about interpreting values from the box plot, and also we discussed how to find the interquartile range, and also we discussed how to find the outliers from this box plot. Okay, so that's all about question number 3. Okay.